Assalamu alaikum guys. This is Najmunisha Asha. Today I came to here to explain about what the building of the periodic table under Unit 1 atomic structure. Let's move on to the chapter. Right. Before start the chapter, we have to know what are the content inside. Actually, we are going to speak here how the periodic table built, right? So according to that, first we have to know the invention of the periodic table, right? And second thing, the periodic table of elements. This is not new for y'all, right? You already studied in your O level the introduction of the elements, what is mean by elements, who discovered, who invented about the periodic table, and just the elements, only the 20 elements that you have studied, but there is not only 20 elements, we will go through one by one, right? Next, names of some groups in the periodic table. As you know, right, you might study it in your O levels, right? The first and second group you can categorize as the alkali metal, alkali earth metal. So we will study like that. You have the several groups of the element and they have the several names. So we will go through that one by one. And next, this is very important, the regions of the periodic table. You should have a clear idea about these things according to this periodic table. Then only you can study about what the inorganic chemistry, the unit 6, right? Let's move on to the chapter. First, we see the introduction. So introduction, I'm going to speak about what? The invention of periodic table, right? The discovery of the chemical elements has been ongoing since ancient times. Yes. The gold, yeah, it's appear in nature element form, thus discovered thousands of years ago. In contrast, some elements such as you can say the technetium, okay, technetium, Tc are radioactive and intrinsically unstable. This word is very important. Whenever we speak about the radioactive element, right, these elements are really unstable and were discovered after development of technology during the 20th century. Yes, the chemical elements are that would have been discovered the earlier time, that you can say the ancient time. The 1,000 years ago, the gold, which we are using the elemental form, right, Au, it's appeared in the nature. But contrast, later also after the technology developed, also they have found another one or two element. That is what the one is, the technetium, right? So this is what we are calling is, if it is unstable, they always radioactive are unstable. So then what happened? As the number of known elements increased, right? So this is what is happening here from your ancient time. The number of elements are discovered by the scientists, right? As the number of elements discovered, right, that increased, scientists began to classify. This is what happened. Yes. If the number of elements increased, you can't say this is what this was for that sake. They wanted to be classified, right? So for that, in 1869, Dmitry Ivanovich Mendeleev in Russia and Lothar Meyer in Germany published nearly identical classification schemes. They are the person, they want to introduce the classification of the elements. So they have derived the idea, both noted that similar as chemical and physical properties occur periodically. So this word is very important. Let's remove the addition, right? So what they said is, the noted, right? They said the similar chemical and physical properties occur periodically. That word is very important. That's what the periodic table discovered, right? When the elements arranged in the increasing order. of atomic mass. So you know what is meant by atomic mass. This is what earlier lessons, earlier presentation we have studied what is meant by atomic mass, how it's discovered one by one, and they have noted clearly the chemical and physical properties occur periodically when the elements are arranged in order in increasing the atomic mass. That is very important, right? Therefore, then scientists at the time had no knowledge about atomic mass. Why I said the atomic mass? Then why I'm speaking about this atomic number? Yes, that time the Dmitri Mendeleev and the Logomayev, they don't have any idea about this atomic number, right? So what they have done is they have stepped into the numbering methods of the periodic table. Let's go for this next slide. Before that, give me a second. I just want to clear all the stuff. Yes, next. So, however, with the introduction of the concept, the atomic number, the modern periodic table was constructed. So he is the person, then by identify about what the name called is the atomic number, right? They are the person, the Dmitri Mendeleev and the Lothar Meyer, they conclude and they can found the modern periodic table according to what? The atomic numbers, right? So let's say we want to show the periodic table of elements. This is what the new trend of the periodic table now also we are using. Just keep on your eyes, guys. So you have studied in your O-level, right? That is only just the 20 elements, okay? Right. But here, can you all see, is it a 20 elements? Right? So there is 103 elements, right? You can see it very clearly. There is 103 elements present. Fine. So not only 20. So according to that, this is what they said. What is the basic concept is the physical and the chemical properties are increasing the periodically. According when your atomic mass is increased, then they reveal the name called atomic number. You can see according to that your atomic number, this table is constructed. So this is what we are calling this vertical axis groups. You can see 1, 2, 3, 4, 5, 6, 7 up to 8. And this horizontal line belongs to what period? You know that one, but you should be able to understand. And guys, so you can see the different colors. Later also we are going to study about those things, right? According to that, this what we have, you can see this yellow. So some kind of the yellow color is alkali metal, right? And this brownish color we are calling alkaline earth metals. Fine. And can you all see these all are the blue in color? Okay, I will use the annotation. Give me a second, right? Yes. The blue in color, you can see this region, right? This blue in color, which causes what? The transition metals. And these are, we are calling it other metals. Why this is a one color, this is another color? Guys, you will study later. Okay, we want to study about what is the S block, P block, D block. That is what we are going to study under inorganic chemistry, right? That's why we said this is belongs to the D block. That's why it's we are calling it a transition metal. This is belongs to the P block, so that's why they said it's a other metal, right? And these are metalloids. What is mean by metalloids? The gray color. Yes, the metalloid says what? Either they can act as a yes metal and a non-metal. That's why they are telling us a metallized. That means the in between state, right? And finally, you can see the pink in color. Those are the non-metal. And the group 17 belongs to what? The halogen, right? Halogen, you already familiar, I think so, right? And your group 18, the purple in color, those are the noble gas. Actually, guys, I'm not going to speak about what this orange and this green color. The atomic number 57 to 71, 89 to 103. This expanded area will become inside this. Okay, you can't see those things, that's why we expanded and show you all like this, guys. We are not going to speak about what lanthanides and actinides. You don't need about that, right? We are not going to speak about those things. So let's we move on to this. This is not very crucial to you all, right? You know how to find the atomic symbol. The platinum is the atomic symbol which lies up. This is the atomic number. Lies down is what? The average atomic mass, right? That figure, what we have seen here. This is that figure, right? How they are numbered. Finally, according to the IUPAC method, you have to number this column according to this what? 1, 2, 3. Not with a Roman letter. Yes, not with what the Arabic letter A and B. That is just a number which numbered as 1, 2, 3. So the electron configuration of the elements corresponded to their location in the periodic table. Yes, guys, we already studied about the electron configurations. When you are writing the electron configuration, you should know the what is the atomic number. Yes, that atomic number is the location of the periodic table. Can you see how they are numbered, how they arrange this? Yes, when you say hydrogen first, that is the person is situated first. That means what? The atomic number of hydrogen is 1. If you take chromium, what is the atomic number? That is 24. If you take what? The potassium, what is that? 20. If you take oxygen, what is that atomic number? 8. So you should be able to say about those things by looking this periodic table. Actually, in your exam, definitely you will get this periodic table. You are not supposed to by heart these things. Why? The atomic mass, average mass you need, and the atomic number definitely you need for the question and everything. So we are providing in your paper, right? So whatever it is, even though you should have a clear idea about these things, without looking the periodic table, you should be able to attempt the questions, right? So according to that, okay, they have corresponded periodic table. The rows of the tables are called periods, I already said. And the elements of the same row shows the twins of them, their properties. Actually, when you speak about the twins, guys, we used to speak what? If you want to speak about the trends of the previous study later, we used to speak about what? Along the period. Along the period means left to right or down the group. So along the period, what is happening? The left to right, the atomic number is increasing. Down the group also the atomic number is increasing. So what is the character? The periodic trends, how it's varied. Those things are we are going to study here one by one by using that PDF and groups first. So you should be able to name the name, that particular naming system, that is very important. So next, elements in same column, right? Which is shows what are called as group. So this is very important, guys. When we said right periods, okay, let's see, right? If you said what, okay, the period, it explains what? You can say that is the number of shifts. Okay. if you say about the group, yes, it explains but the number of electrons available in your valency shell. Clearly, you can say the number of valency electrons. So this is what, according to that, the period resembles what? The number of shells, and the group is resembles what? The number of valency electrons. So the number of shell, you can know the principal quantum number according to that. Yes, it's not new for you. We know that one. Yes, when you take an atom, you have the different shells like this. Okay, this is according to that. If it is having the 3 shells, we are telling the particular element X is third period. Okay, if you have the element, the electron in valency electron, right? Okay, 2 electrons. So now you can say what is this? The X is belongs to, right? Yes, third period. And what is that group is? Yes, second group. So simply you can understand, guys. So we have studied what these things, and we know about the configuration, right? 1:2, 2:2. This likewise it's increasing. So where you are using that configuration, so we are taking, how would you find the number of valency shell, number of electron in the valency shell? That would be what? NS2, NP6, whatever. Right, let's we move on to the notes. Give me a second. Yes. Okay. So I have talked about everything. The elements are same column of the table, which are all groups related for the outer shell. I already said. If you take an example, okay, the group 2 element have an NS2, yes, outer configuration, and the group 3 elements will show the NS2 NP1. Right? Did you understand? So you should be very careful about that. Let's see, use the annotation. So when you say, right, it is third period, it should be what? 3s2, 3p1. Therefore, you can say that is the third period element and having what? Third group element. This is what the connection between them, right? Yes. So electron configuration of group 2 and group 13 elements is given here. So look at this one. And we know the configuration, we know how to write this. And take this one. So whenever we speak about group 2, right? Okay, when you say that is group 2, that means the valency electrons should be 2. So can you check this is 2? Can you see? Though the period is differing, we are telling this is group 2 now. The valency electron should be 2. If it is group 13, right? 13 means we are telling it's a group 3 elements. You will be clear about why this is called 13, right? So 3 elements, can you see the upper part? That means the S2 will belong to the 2S and 2P, 1 also belongs to. So this is seems to be similar. Can you say if it is group 14 elements, what should be the electron configuration? Right? We'll say the group 14. We'll say the third period. So that should be 3s2. 3 E. That's all. This is the difference. You should be able to answer. You should be able to find it. Right? Okay. So let's be clear all. So elements in a group periodic table 9 and 6 respectively. Because 2 electrons can be placed in the each orbital, each shell accommodates up to 2 n2 electrons. That means 2, 8, 18 and 32. What they are telling us. So if you want, we already studied about this, the maximum number, the total number of the orbitals which you can be seen. If you say n is what? Principal quantum number, your number of shell, right? Okay. The n squared, if your number of shell is equals to 1, your n squared also 1. If it is 2, that is 4. 3 nang 9, 4 nang 60, right? So because of you have the 2 electrons here, that means what? The 1 orbital is equals to the 2 electron. Therefore, you might have 2 and 2. You will end up with what the electrons are 2, 8, 18, right? So therefore, the overall structure of the periodic table to reflect this electrons number. Each row of the table has 2, 8, 18 or 32 elements. So these periodic numbers, which is also explaining about what the overall structure of the elements in electron level. So the periodic table can be further divided into 4 blocks. Why? You can see that is ending with 2, 18 and 8, 32. So therefore, they have discovered the region of the periodic table. Yes, this is your region, guys. These ola is resembles what the oneness group, right? These are S block. Can you see? Shall we use the annotation? And you can see the blue color. These two, right? These two is saying about what? Yes, these two are saying about what? S block. And I already said we are not going to speak about the F block, but you should know about this. And D block is here. And these all are D block. And they are P block. And this is what we are calling bridge. S block is what? The blue in color. F block is it's a beige in color. D block is in the orange in color. P block in pink in color or kind of the reddish in color. We have 4 blocks based on the filling order of orbitals. But we have studied under Akbar rule and Pauli exclusion, electron configuration, presentation. So according to that, we have filled in one by one. So let's move on to the next slide. Therefore, the 2 columns of one left. Okay, I already said. I'll just go through that one. That's known as the alkyl metal. We said the group 1 and alkaline earth metal is a group 2. So this is the valency of where S orbitals are being filled. So why they are telling you, so your maximum number of electron is the S. Maximum orbital is S, right? These 2 columns make up the S block, the periodic table. Yes, fine. The block of far right, the 6th column, but we talk about the right side. Group 13 to group 8, those are belongs to what? The P block. Why? The valency P orbitals are being filled. So you should be very aware about that. Why we are telling the S block, P block? Yeah. When you check your valency electrons, that valency electrons being filled at what? The P orbital. That's why they are calling valency P orbitals. And the S block and P block elements together are representative elements. Sometimes we are called the main group elements. So S and P, we are talking about the representative elements, and those are the main group elements, right? So the block before the pre-block, you can see the 10 columns containing those are the transition metals, I said. are they? They are what? The general practice group 1 to 10 elements are not considered as a transition metal. However, these are the elements in which the valency d electron being filled make up G block elements. This is what we are calling as P block. So the elements 2 rows between the S block and D block containing the 14 column. So you have seen here, right? P block, D block, right? Yours block, D block. You can see 2, 4, 6, 8, 10, 12, 14. The 14 elements, these elements are called as what? The F block. This is what they are. And this is, we are calling it, however, the filling of the electrons and the configurations are complicated, so we are not starting here. Right. So these elements are often referred to as wave block metals or inner transition metals, and we are not going to speak about that much here. The number of columns in each block corresponds to the maximum number of electrons that can occupy each kind of subshell. So you should be able to understand about that. What is the maximum number they can obtain under your subshell? Since that 2, 6, 10, 14 are numbers of electrons that able to fill in under your maximum electron under your subshell, that is SPG. Right? S block has 2 columns. D block you have the 6, D is 10, F is 14. We already studied about this, right? This is not new for you. So when you speak about that, right, your S block showing what? Sorry, S subshell showing the maximum electron. D subshell. What is the maximum? 6. And go for D subshell. D subshell. Electron. And finally go for F subshell. Yes, that is a 14 electron. So this is what you have to understand. Right. So according to this, we are taking each different one, and that is the example and example of this. So a second, I want to clear all. So now we have the clear idea about what the building of periodic table. So with this is what we are telling today. A small introduction about the periodic table. That means how you can handle the periodic table. Once you look, you should be able to understand what is inside, what they are telling majorly. Those things are very important. So with that, I will end this note, right? So inshallah, we will meet you with the next presentation. Until that, see you. Bye bye. Assalamu alaikum wa rahmatullahi.